Okay, next is chapter 7, okay, K and N, and from this point onwards, all our methods are for classification mostly, though you can use each one of them for regression as well. So we're going to use this diamond1.csv data. Okay. So dm.df, it has a number here as the first column, and we're going to use high.margin as our target. So price is a numerical target, so that's not a predictor, so we need to remove that and use high margin as our target. So we're going to remove the first column called number, and then we're going to remove price. So those two are gone. Okay, now we're going to check for missing values. So we have length and depth. These two have missing values. Okay, so we already talked about imputing with mean or median or with mode. So I'm going to just jump in and impute both length and depth with mean. Okay, so that's going to impute. Now we can go back and check. Okay, run this again and make sure that there are no missing values. Okay. Now K and N, okay, we're going to compute distances, and therefore we can't have factor variables. If you have factor variables, they'll have to be converted into dummy variables. That's number one. Okay. For K and N, what kind of data preparation we have to do? First, all the dummy variables need to be converted to, all the factor variables should be converted to dummy variables. The second is all the numerical variables must be normalized. Okay. You can use either z-score normalization or you can use range normalization. But usually z-score normalization is what is used. So those are the two things that we have to do before we can train the model. So we're going to first, okay, so here we do an STR and we see what the factor variables are. Factors are cut, color, and clarity. Okay. One cautionary note. Okay. If you have categorical variables that are numeric, it's not going to be your strings as factor is not going to automatically bring them as factors. You may have, say, category of something like severity, okay, 0, 1, 2. That's a categorical variable. But read.csv with strings as factors will not convert that into a factor because it is not a string variable. It's a numerical variable. So you have to be careful. Okay? Don't just look at the factors alone. Okay? Look through the variables and make sure if there are factor variables that are coded as numbers, they are converted to factor. Okay, you do it yourself with either factor and level and label or just simply as factor. You have a question?
Oh, no, I'm sorry.
Okay. All right. So now I'm going to separate out these three factor variables, okay, and I'm going to use dummy vars from Caret because here, okay, you need to, when you convert to dummy variables, you can either say full rank is false, which means you will have one dummy variable for each possible value of the category. If you have k categories, you will have k dummy variables. Okay. which is what we want in K and N. But when you are using regression or neural network, then we do want full rank only. So full rank means when you have K categories, you need only K minus 1 dummy variable. So if you want K minus 1 dummy variables, full rank must be true. That's the default. You don't have to say anything. You will get full rank dummy variables. Okay. Full rank means K minus 1. Okay. But if you want dummy variables for each category, then you have to say full rank equal to false. Okay. And in K and N, that's what we want. So say full rank is false, and then you need to do predict. Okay. Now, when you're using dummy vars, the predict is going to give you back a vector. Okay, so you need to convert that into a data frame. So that's going to convert, or that's going to prepare dummy variables for all the factor columns. So dm dum is going to have, see here, let's do a table of cut. So these are the possible values for cut: fair, good, ideal, premium, and very good. And you have one dummy variable for each category. Okay, 5 of them. Okay. If you did full rank equal to true, okay, then you see you have only 4 dummy variables for cut. Okay, so that's the key. So we're going to put it back to false. So we have the dummy variables. Okay, so now we're going to combine. Now we need to put the dummy variables in and take the original factor variables out. Okay, so the first line of code here, cbind. So it takes the original data and then it adds these new columns, adds the dummy variables. Okay. So now it has the original factor variables as well as the dummy variables in the data set. So we need to remove the original factor variables, and that's what is happening here with subset. Okay. Okay, so now dm dum df, okay, so it has all the original numerical variables, it has the target, and it has all the dummy variables, but the original factor variables are now gone. Okay. So now we do the partitioning. Okay, so train and valid. And then we have to do the normalization. Okay. Now we use the train values to figure out the normalization parameters and use those parameters to normalize both the train and valid data set. So you now, I'm going to list all the numerical variables and do a pre-process of just that num variables, and the method is center and scale. So that's going to give us the z-scores. And use this object, which is set up with the trained data set, and then we're going to do normalization for both train and valid. Okay. All right. So now we have the partitioned data dum.norm.tr. You see that all of them, all the numerical variables are z-scores. You have the target and then you have all the dummy variables as is. Okay. The preprocess only processes the numerical variables to z-score. Okay. Same the case in valid. Okay. All the dumb valid. All right, so now we're going to train using. Okay, so I'm going to review just one. So we can use K and N from the A and N library. So by itself, you can specify a particular value for K. But here, I'm going to use caret to run a combination. I'm going to give a tune grid here, which is the data frame of the different values for K that we want to use. And the sampling. I'm going to use cross-validation with number of folds equal to 6. Okay. And then you set seed. Now you have train. And as factor the target. And then the X is the normalized train data set. Okay, and then the sampling train control is for sampling, and tune grid is for different values of K that we want to use, and then we have the K and N method. Run that. Okay. And after that, once it is done, then you can use the K and N object, okay, to predict. You can do prediction and you can do probability. So if you don't specify type, then what you get is prediction, which class each observation belongs to. Okay, class prediction. If you use type equal to prob, then you'll get the probability. Okay. So now you see KNN dot pred, you see there are two levels, zeros and ones. It gives you the predictions. KNN dot prob, that gives you probability of 0 and probability of 1. Okay. So if you want confusion matrix, you use this prediction. Okay. And for ROC chart, you use this probability of the positive class. You want to make sure that you use the correct class, so the ROC chart is above the diagonal. Okay. Don't have an ROC chart that's below the diagonal. Yes? You have a question, Joel?
You said that we would use the probability one for an ROC chart and the
for ROC chart.
And predict one for what?
For confusion matrix. Okay, so this one for confusion matrix, this one for ROC chart. Okay?